Hey guys, so I'm back with question 3 of October number 2013 chemistry level 9701 paper 23, which is paper 2 variant 3. This is for the AS level. I hope you know that. Let's start off. Yeah. Okay. I did part 1 and 2 in another video, and I'm gonna upload it together with this one. So if in case you haven't got the notifications on, you haven't subscribed already, just subscribe in and hit the bell icon so that you know whenever I make the next question paper. And of course, subscribe to me, click on my icon, just visit my video section, and you must know that I've uploaded quite a lot of videos on chemistry A level, and then you can see them all if you want, that is. Okay, so moving on, the elements of group 7 of the periodic table show variation in their properties. Complete the table below, stating the color of each element in its normal state at room temperature. So they want it at room temperature, so the color of chlorine is of course greenish. The next one is bromine. You can say it's reddish brown, or you can just say it's reddish, or you can just say it's reddish brown, because that's the color it's actually is. If you don't know, if you don't want to put such a wrong thing, just you can put reddish or brown. I prefer to put both. Iodine is of course depends on its current state. You must know that they have asked in at room temperature. At room temperature, iodine is a solid, so it's a purple solid. Oh, purple. Briefly explain why the melting points of the halogens increase from chlorine to iodine. So what do you think that is? It's due to van der Waals forces, right? Because the number of electrons in an atom increase from chlorine to bromine, from chlorine to iodine, to iodine, the van der Waals forces. The Waals forces in between the molecules. Between molecules increases, and therefore the intermolecular forces, I'm just using the short form, decreases. Sorry, not decreases, increases, and the melting point increases. I'm just writing short form so that while it would happen quicker. Okay, halogens form many interhalogen compounds in which two different halogens are combined. One such compound is bromine monochloride, BrCl. Complete the electronic configurations of bromine and chlorine. Okay. So you must refer to the periodic table given at the end of the data booklet. If you don't have a data booklet, visit my other video where I state that I have a lot of A-level materials, and send me a mail at the email ID given in that video, and I'll respond to you. Okay. Anyhow, chlorine has a number as an atomic number of 17, which means that it has 2 and 6, right? That adds up to a total of 10. Means there's 7 electrons still waiting to be sorted out. So 3s2, 3p6. So that gives you 2 plus 2 plus 6. 18. So that gives you 18 electrons. But wait, is it 18? Yeah, it gives you 18. So we didn't want 18, we just wanted 17. And by the way, you must know that the 4s shell fills up first. So the 4s2. So, and then you've got the remaining fitting into 3p, into the 3p orbital. So it's a total of 17 minus 2 minus 2 minus 6 minus 2 minus 2. Gives you 3, so I have just 3 electrons here. Okay, 1s2. So bromine has 35, so it's gonna expand to much more. 3s2, 3p6. I'm just gonna put 6 because it's definitely much more than the 3p can hold. 4s2, 4p6, 5s2. Sorry. Oh, and I forgot one thing. Oh, here I just forgot one thing. Actually, the electronic configuration doesn't look like this. There had to be a 3D orbital, which I missed out. Okay, so it's 3p6, 3p5, sorry, and it ends there. Okay, with 7 electrons in its outer shell. Yeah. 3p6, 3d10, 4s2. So I have an approximation here. So 2 minus 2, sorry, 35 minus 2 minus 2 minus 6 minus 2 minus 6 minus 10 minus 2 still gives you 5. So you still have 5 to arrange. So that gives you 4p5. So you can see there are too many electrons. There are a dot and cross diagram of the BrCl molecule. Show outermost electrons only. So I've got Br and I've got Cl, and then there is a covalent bond. That's about it. Because there's nothing more. Interhalogen compounds like BrCl have similar properties compared to the halogens. By considering the physical state of predict the physical state of BrCl at room temperature, explain your answer. So you can say it can be solid because it has got too many electrons, right? Or you can say it's a gas. Each one, gas, liquid, solid. I'm gonna give you a moment to think. We're about to do it? Okay. So it's actually a gas. And why is that? So in a Br molecule, there are 70 electrons, right? 35 from the Br2 molecule. So there's 35 from the first one and 35 from the second one. Here, B and Cl2, there are 17 molecules. Sorry, 34. This gives you a total of 70 plus 34 gives you 104. Now you got BrCl. Now you've got a Br atom and a Cl atom. So that gives you 35. That gives you 17. So 35 plus 17 gives you 52. So 52 out of 52. So you see it's it's in between Cl2 and Br2, right? 52 is in between 34 and 70. So BrCl has to be in between Cl2 and Br2, right? Right? So Cl2 is obviously a gas, so it's safest to say that this is a gas as well. Or you can say it's a low boiling liquid because BrCl molecule has more electrons than chlorine. but less electrons than bromine. Chlorine. Wait, there's a magic word. There's a gas. So to show that it is Cl2 and not just Cl. But less than Br2, right? So it's van der Waals forces. So it's, they've given you quite a bit of space. So it's van der Waals forces are stronger than Cl2 but weaker than Br2. So this is what we call prediction. Okay, we must know that the melting point is greatly influenced by the electrons in halogens, as we wrote up here. Right? Okay. Describe. Okay, Cl2 and BrCl each react with aqueous potassium iodide. Describe what would be seen when chlorine is bubbled through aqueous potassium iodide for several minutes. Initially, solution begins to turn yellow or brownish. Oh wait. By the way, I just remembered iodine vapor is purple. It's not iodine itself. So iodine itself is black. Okay. So another thing. Oh, another thing we forgot. So just the color of BrCl, it's a cross between Br and Cl, right? So it should have the reddish color and the greenish color. What do you think? It's orange. Right? It can be orange. Because Br is red, Cl is green. What happens when you add red and green? You get orange, right? Initially, solution begins to turn yellow. Solution begins to turn yellowish. We write ish colors because we can't guarantee a color. After several minutes, like if you can absolutely guarantee the color, like iodine, I know for guaranteed that it's black, so I just write black. Okay, we write yellowish because it can form yellow as well as brown, so we just write yellowish because we can't be too sure. After several minutes, so the iodine will be displaced and you will have a dark black solids as mentioned above. Because they've asked for observations, you don't go and state that you've got iodine there. When they ask for your observation, you've got to imagine the experiment or the whatever reaction they've given you and think as though you were a lot younger. Like when you're a kid, you'd be maximum able to say that turns yellow and there'll be a black thing coming out. So that's the maximum you'll be able to say, right? Exactly the thing that they need in here. So you've got to imagine the experiment and then carry it out in your brain and watch it as though you were 10 years old. Construct an equation for the reaction that occurs. So of course you've got BrCl, so of course Cl2 because they added Cl2 there. And they've got potassium iodide. I'm leaving a bit of space so that I can add any numbers if I want. So of course you must have iodine because that's the thing being displaced. So you must have KCl. You must have two of this and the simple balancing, two of this, right? Or you can have half and half. It doesn't make a difference. So okay, so now suggest a equation for the reaction that occurs between BrCl and aqueous Ki. Right? So of course you need BrCl. KBr. Sorry, Ki. So you've got two molecules to displace, right? So each molecule displaces one. Okay? So you've got KCl and you've got KBr and you've got iodine coming out. Whatever it is, you've got iodine coming out. So it's almost like there's a ClCl. Here you have a BrCl. So you've got to replace everything you see with one Cl with one Br. So there's one Cl here. So it's like KCl plus KCl. So you need to make it KCl plus KBr. Okay. How do Cl2 and BrCl2 behave in these reactions? So you must know it's oxidizing agent. Why do you think it's oxidizing agents? Because they are being reduced in the process. No, maybe. You have noticed that the iodine, for iodine, so we are gonna take the simple example. Originally it has a charge of -1. When it goes here it has a charge of 0, right? So this is iodine is being oxidized, right? So it means that the other thing must be being reduced. So you can say this is a redox reaction. Yep, it is a redox reaction. Okay, so we are at question 4 now, which will be done in the next video. I don't want to put in too much into one video. People said they're bored watching my videos because, well, they couldn't skip to content they liked. They couldn't skip to the question they liked. Okay, so bye guys, and see you in the next video, which will be quite soon. I'm even upload 2 of these videos together.